This video is a continuation of the list notebook and will describe Python list slicing. So at this point, we can manually create lists and index single elements from those lists. Slicing is similar to indexing, but allows us to access multiple elements. Now, for those of you that have already gone through the string notebook on slicing, this is going to be very familiar. First, let's remind ourselves of the contents of the squares variable. This list contains the squares of the integers 1 through 5. And now, similar to indexing, we're going to use square brackets in order to access the elements of the list. But we're going to introduce a little bit of new notation in order to access multiple elements or a range of elements from the list. So I'm going to write squares, and then I'm going to use square brackets like we did with indexing. And if we're interested in accessing, say, the second and third element of our list squares, we're going to start with index 1, and then I'm going to write colon, followed by the index 3. Now, the first entry in the slice 1 is the start index and specifies the index of the first value in the list that we want to appear in our output. The entry that follows the colon, 3 in this case, is the stop index and is 1 past the last value that we want to appear in the output. This means that the slice is going to start at index 1 and take all elements of the list up to but not including the element at index 3. So when we run this code block, you see that we get elements 4 and 9 from our list, which are from index 1 and 2. And notice that we did not get 16 from index 3. Also notice that the output of a slice is a list, whereas the output of an index operation would have been the value itself, or an integer in this case. In fact, the output from slicing a list is always a list, even if it contains no elements, as in this example, where we start at index 1 and go up to but not including index 1. Which of course results in an empty list. And it's even the case if the slice would result in a single element. So if we were to start at index 1 and go up to but not including index 2, you'd see that we get a list containing the element 4. Similar to indexing, slices may use both positive and negative indices, and they can of course be mixed. So if I were to create a slice starting at index 1 and going up to but not including negative 1, recall that negative 1 refers to the last element in the list, we would actually get the middle 3 elements of this list that returned as output. Likewise, if I was to start a slice at negative 3 and go up to but not including index 4, negative 3 in this case actually refers to index 2, since we have 5 elements. And so the output here for this slice contains elements 9 and 16 from indices 2 and 3. Also, the interpreter does allow for a bit of shorthand when dealing with slices, and that we can omit certain indices. So let's say we wanted to create a slice that starts at the beginning of our list. We could omit the first index and simply say colon, say -3 here, and this will return all elements in the list, starting with the first and going up to but not including -3, which refers to index 2 in this particular case. Likewise, if we wish to create a slice that goes to the end of the list, we can omit the stop index and say maybe 1 colon, and the output would include all elements starting at index 1 going to the end of the list. Slicing also supports a step size. If we add an additional colon after the stop index, we can follow it with a step size. Now the default is 1, as we've seen, but we can modify this to say 2, for example, so that we get every other element in the list between our start index, 1 in this example, and our stop index, 5. Now, in the previous section on indexing, we saw that use of indices outside of the range of the list resulted in an exception being raised. With slices, the situation is a little different. For example, let's say we create a slice with start index 4 and a stop index of 42, which is well beyond the end of our list. When I run this block, you see we get the output 25, and no exception was raised. And the reason for this is a slice starts at the start index and sort of linearly marches through your list up until the stop index is reached or there are no more elements. Also, if I was to give a start index that was out of range, we would still not get an exception. So for instance, if I create a slice that starts at index 42 and goes until the end of the list, we would see that we get an empty list returned to us. And this actually makes sense, since the slicing operation will return to us all elements between the indices given. And since the given indices are out of bounds, there are no elements between them. Hence, we get an empty list as output.